All right, guys, so we are here working on, from your workbook, again, if you have it, Thinking with Mathematical Models. We're on page 38, starting in lesson 2.3, where you are going to learn how to write your own equations from a word problem or a problem that has context, right? We've been learning about how to do that from a graph, right? But it's also important to be able to read a situation and model it with an equation. So this one's about Treetop Fun. It says Treetop Fun, TTF for short, runs adventure sites with zip lines, swings, rope ladders, bridges, and trapezes. The company uses mathematical models to relate the number of customers, prices, cost, income, and profit at its many locations. So the really important thing about this is that this company uses mathematical models. That's why these exist, so that we can use them in the real world. You're learning about how to use them, or how you can solve them and use them, because in life they apply to these real life things, like how do you manage a company and how do you manage profits and income. So we're going to do this example together, and then you're going to work on some from page 39 on your own. So problem 2.3 says, when finding an equation, it may help to calculate values of dependent variables for some specific values of the independent variables. Then you can look for a pattern in those calculations. You can use the information given in words, tables, or graphs. So let's see what they want us to figure out, and we're going to look through and see, do we want to use words, tables, or graphs? A, use what you know about linear equations to work out the models for Treetop Fun business. Find an equation for each of the linear functions described below. So we're writing an equation for all three of these scenarios. So scenario number one says the standard charge per customer at TTF is $25. Write an equation that relates the daily income, I, to the number of customers, N. So I'm just going to write what we know. So for number one, we know that they charge $25 per customer. So to get into this park where they've got zip lines and swings and all of these things, they charge each person $25. So how can we figure out their income, which is how much money do they make? How can we figure that out? Well, they earn $25 per customer. So their income equals $25 times the number of customers, right? That's how much money they make a day. So if they only have one customer, they make $25. If they have two customers, they make $50. So let's write that with some variables. They told us the variables. So what did they tell us to, instead of writing the word income, what variable did they tell us to use? They told us to use I. So I'm going to replace that with I. Equals is equals. They make $25 per customer, and then it says the number of customers, N. So they want us to use the variable N for customers. So this is our linear equation. To figure out how much money they make in a day, an hour, or a week, you just take 25 and multiply it by N, the number of customers they had in that time period. And what do we know about this? We know that because the 25 is next to the N, that our slope is positive 25. And what's our y-intercept, our b? There is no plus anything, it's just 0. And that makes sense, because if they have 0 customers in a day, they make $0. And each customer that comes in, they make another $25. So that's the slope, because each time it's plus 25. So this has just got different variables, but it would be the same if I wrote it like this. Same, right? You're just thinking the x is now n and the y is now I, because they told us that. Variables, you can use whatever you want. The most commonly used ones are y and x, but you can put whatever letters you want. And this problem told us what to put. So that's number one. Okay. Number two says each TTF site has an operating cost of $500 per day. Write an equation that relates the daily profit P to the number of customers. So now we're adding on this thing about operating costs to what we know about number one. So let's write that. Operating cost is $500 per day. Okay? And so what's an operating cost? An operating cost is I'm just trying to see what they want to say. An operating cost is things like the electricity, the rent, paying the people who work there. So what this means is every day that they open, it costs them $500 to stay open. And then after that, they make $25 per customer. So they want us to write a new equation. They want P to be profit. And they want N to still be number of customers. So I'm just going to write that. And we have to write an equation for profit. So profit just means how much money you make after you pay off all your debts. So profit means how much money am I making after I pay off all my debts. So my profit is going to be equal to, well, they still make $25 per customer, so 25 times N, right? That part's still true. That's how much they make. So this is their income, right? And then what else do we have to deal with? They have to deal with their debt or their payments, or what they call operating cost. Debt, I spelled it wrong. And their debt is each day they have to pay $500. That's why I'm subtracting $500 from that. So my profit is how much I make from the customers, take away that $500 I have to pay to stay open. So this is my new linear equation. My slope is still 25, right? But now what's changed? My y-intercept has changed. Now my y-intercept is negative 500. Basically, every day they open the doors, they're starting out $500 in the hole, and they need to make some money to get back up to zero, right? You could actually use this equation to figure out how many customers they'd have to let in so that they break even, right? They need to at least make $500 so that they don't lose money that day. And the last one we're going to figure out, it says, one TTF site bought a new rope bridge for $4,500. TTF will make monthly payments of $350 until the bill is paid. Write an equation for the unpaid balance B after M monthly payments. So I'm just going to write what they told me. B is the balance. M equals monthly payments. And they are paying, it said, $350 per month. So that's their bill that they're paying until they pay off the total. So to figure out their balance each month, well, let's think. If we are starting out day one when they buy the bridge, their balance, what they owe for that bridge is $4,500, right? And then after the first month, their balance is going to be whatever $4,500 is minus that $350 they pay the first month. So how can we find the balance? Well, the balance is going to be equal to that $4,500 they owe, take away 350 times how many months they've paid it, right? Because if I came up here and filled this for 2 months, it would be 4,500 minus 350 minus 350. I'm taking away two 350s. If I'm in the third month, it's going to be three 350s. So this is the balance. So if I were to rewrite that with just variables, my balance is 4,500 minus 350M. Okay, so this one is like slope-intercept, but a little bit backwards. So if I were to rewrite this in slope-intercept form, it would be equal to negative 350M plus 4,500. If you need to rewrite it like that so you can pull out the slope and the y-intercept, you can, right? Because now I can see that the slope here is negative 350. Each month, their balance goes down $350. And the y-intercept starts out at 4,500 because that's what they start off with owing. When they first open this account, they owe 4,500, and each month they pay off $350. So that's the slope and the y-intercept. So you're going to start writing your own equations and then trying to figure out, now that I have this equation, how can I pull out the slope? How can I pull out the y-intercept from what I know? All right, so now you get to try those problems on page 39. I'll see you later.